So hello everyone, myself Mayank Sharma, and today I will be explaining maintaining casual ordering in Group Multicast using a simple distributed chat system case study. This topic belongs to distributed computing, but don't worry, I will be explaining everything in very simple language so that everybody can understand. So let's begin. First of all, we'll be understanding what is a distributed computing system mean. A distributed system is a system where multiple independent computers are connected through a network. Each computer works independently. They do not share memory. They communicate by sending messages to each other. There is no single master clock controlling everything. Because of this, distributed system must handle network delays, failures, and multiple processes running at the same time. And this is where message ordering becomes very important. So next we'll be understanding about group multicast. Group multicast means sending one message to multiple group members at the same time. So basically this means in short one sender and multiple receivers. All groups members are supposed to receive the same message. This commonly used in chat systems like WhatsApp, online collaboration tools, distributed applications, but ensuring that everyone receives the message in correct order is not easy. So next we'll be discussing about that only, that is the message ordering problem. In distributed systems, network latency is different for each path. Messages may take different routes. There is no global clock. Because of this, messages can arrive in different orders at different computers. This can create inconsistency or confusing results. So next, we'll be understanding about types of message ordering. So there are different ways to control message delivery order. First of all, we'll be considering first in, first out ordering, that is FIFO ordering. This preserves order from the same sender. Second, total ordering. This ensures every process sees messages in exactly the same order. Third, casual ordering. This preserves cause and effect relationship between messages. Different applications require different levels of consistency. Today, we will be focusing mainly on casual ordering. So let us understand what is casual ordering mean. Casual ordering ensures that dependent messages are delivered in the correct logical sequence. It is based on something called the happened before relationship that we have seen in the previous slide as well. If one message influences or causes another message, everyone must see them in the same order. If two messages are independent, they can be delivered in any order if there are different messages. This avoids logical confusion without requiring strict total ordering. Next, we'll be coming on to the main topic that we were going to discuss today, that is case study on distributed chat system. So consider three processes over here. First of all, P1 that is handled by Alice, P2 that is handled by Bob, and P3 that is handled by Charlie. So first of all, Alice sends a message that there is a meeting at 5 p.m. Bob reads it and replies, okay. Now logically, Bob's reply depends on Alice's message. But because of network delay, Charlie might receive OK first and then later he might receive meeting at 5 p.m. So this creates confusion. It looks like somebody said OK before even knowing what it was about. Casual ordering ensures that Charlie must see the meeting message before seeing the reply. So next we'll be considering what shall be the solutions for these problems. So we'll be seeing a solution named vector clocks. Now let's see how we can solve this. We use something called vector clocks. Don't worry about this name. Think of it as process maintaining a small list of numbers. If there are n processes, each process keeps a vector of size n, that is the same as the number of processes. Initially, all values are set to 0. Before sending a message, the sender increases its own counter. Then it attaches this updated vector to the message. So now let's see this implementation into our example which we had taken in the previous slide. So suppose we have three processes same as the previous example, that is P1, P2 and P3. The step 1 will be P1 sends message M1, so its vector count should be increased by 1. So that's why it is written 1, 0, 0. Step 2, P2 receives message M1. It updates its vector to 1, 1, 0 so that while P3 receives the message, he should know that he has to read P1 and then P2 in the order. Then P2 sends reply M2. Step 3, if P3 receives message M2 first with timestamp 1, 1, 0, P3 checks its own vector. There is a delivery condition. Actually, there are two conditions. First is the sender's value must be exactly 1 greater than the local value. All other values must be less than or equal to the local vector. If this condition is not satisfied, the message is not delivered immediately. Instead, it is stored in a temporary waiting area called a buffer. P3 waits until it receives M1 with timestamp 1, 0, 0. Only then it delivers message M2. This guarantees casual ordering. Now let us understand what are the challenges in implementing casual ordering. Although vector clocks solve the problem, there are some challenges such as vector size increases as the number of processes increase, comparing timestamp adds computational overhead, buffering messages uses extra memory, scalability becomes difficult in large distributed systems. So while casual ordering is useful, it comes with implementation costs. Next, we'll be understanding the conclusion. So let's summarize all the things that we have studied till now in simple words. Distributed systems face message ordering issues because multiple processes run independently. Casual ordering ensures that messages that depend on each other are delivered in the correct logical sequence. Vector clocks help track these dependencies. Buffering ensures safe and consistent delivery. This concept is very important in distributed chat systems and many real-world distributed applications. That's all for the day. I hope this explanation made casual ordering clear and very easy to understand for you all. If you found this helpful, please like, share and subscribe my channel. Thank you for watching.